Hello, welcome to the physics virtual class. Okay, in the last class, we were discussing the new chapter, that is electricity and magnetism. And today, the date is 27 August 2020. We will be continuing with the same chapter, electricity and magnetism. In the previous class, before we concluded, we had discussed two topics there, or two what you call physical quantities in this chapter. The first one was the charge, which was denoted by the symbol Q, and it was nothing but the amount of electrons present in a conductor or in a wire. So it was given by this Ne, the formula. N was the number of electrons present in the conductor, and plus and minus indicate the positive as well as the negative charge. And the unit for this was given as coulomb. Okay, the unit was given as coulomb, which was denoted by capital C. Then we discussed another important topic, which is the current. It was represented by the symbol I, and the current was defined as the rate of flow of charge. So I was given as Q by T, and the unit for the current was given ampere, which was represented by capital letter A. So ampere means how much of current flowing in a wire. Suppose we say 1.5 ampere, capital A. Now, to continuing this chapter, we will discuss two more important topics today. That is the potential difference, which can be taken as one topic or one physical quantity, and the second one is the resistance. Let us take potential first. In order to understand a potential, we first have to know a little bit about charge. Charge, we all know there are two types of charge, like the positive and the negative. So when the like charges are brought closer to each other, they will repel. Suppose the two positive charges are brought closer, they will repel. And if the unlike charges are brought closer, they will attract. Suppose the positive and the negative charge are brought, they will attract. So now let us take from a region, a point A, and there is a point B. From point A, you are carrying one charge to another point. Suppose a charge from A is carried to a B where you have a like charge, then there will be repulsion. So in carrying, what is the key thing that you have to keep in mind from the physics point of view? You do the work. Work is done against the force of repulsion by this charge A when it is carried from one end to another. Okay, so the key thing is work done. But here, since you are taking to the like charge, charge is being carried to another region where you have a like charge present, so the work is done against the repulsive force. So this is your first case. In the second case, suppose you take a charge to the unlike charge. Suppose here you have a like charge, and there you have a force of repulsion. Repulsive force is taking place there. And when you take the charge to the region of unlike charge, then you have a force of attraction, attractive force. But in both the cases, what do we observe is there is a work done. Alright, so work is done basically when you carry a charge from one region to another. Either it is a repulsive force due to the repulsive force, or it is by the attractive force. So what we come to a conclusion here is, now potential, it is nothing but it is measured in terms of the work done. In terms of work done in moving a charge from one region to another region. So now we can define the potential like this. Potential is defined, potential at a point is defined as the work done per unit charge. Keep that in mind. It's defined as the work done per unit charge in bringing a positive test charge from infinity to the from infinity to that point. Okay, so I'll repeat this again. Potential at a point is defined as work done per unit charge. Potential at a point is defined as the work done per unit charge in bringing a positive test charge from infinity to that point. Let me just explain this definition. You can refer to this definition in the textbook. It is already there in page number 177. Okay, so if you see here, suppose you have a positive test charge. Now this positive test charge, let us say it is at infinity. Let us take it as capital Q. Now this test charge is brought from infinity, a very far distance, to a point P. Suppose it is brought to a point P. Okay, and this point P is in the region of the positive. It is in the region of a positively charged body. Suppose it is positively charged body. So this is a region. In this region, you take one point, and at this point you are bringing a charge from infinity. So in doing so, what you are doing? You are doing the work. The work is being done. So that work done per unit charge, that work done per unit charge will be defined as the potential. Now this we have taken as a test charge here. Now this test charge is a charge of very infinitely small value. The presence of this test charge does not disturb the other charges when it is brought to the region of other charges. So now let us write down the expression for the potential. Okay, the expression for the potential is quite simple now. So we have understood the concept. In the potential, the key word or the key point you have to keep in mind is work done. Work done when you carry a charge from one point to another. So in the potential, what is one point? The first point is infinity. It is coming from infinity. It is coming from infinity. The charge is coming to a region where it is already positive charge, and you are bringing the charge from infinity to the point, and while doing so you are doing the work. So that work done is measured as the potential. So let us write down the formula for the potential. This formula is very important from your exams point of view. You are going to get some simple numericals on this. So potential is work done divided by the charge, unit charge. So this potential is given by the symbol V, and work done is given by W, and the charge is given by Q. So learn this point, this formula. Potential is equals to W by Q. Alright, now we go to the unit, SI unit of the potential. So potential is, so this is the third term, or third, what do you call, third physical quantity we have learned. The first one was the charge Q, the second one was the current I, and the third one just now we have learned is the potential V. So unit of the potential, it is quite simple, the unit of the potential. Let us take the formula. We have learned that in the previous chapters, in the previous class, the unit for the work done is given as joule, and the unit for the charge which we have learned in the previous class is coulomb. So joule per coulomb. When it is taken up, Now this joule per coulomb, we can also take it as joule per coulomb, can be also called, can be also given the name volt. Volt, we can also call it volt, or this volt can be also used the same symbol V as the potential. It is given in order, in honor of the scientist, or the name of the scientist is something like Alexander Volta. Okay, he may be some French scientist. So therefore the unit of potential V is volt. Sometimes volt can be also written as V. So here if you see that the symbol for the potential and its unit are same, both are capital V. So you should not be confused. Whereas in case of the current, the symbol of the current is I, but its unit is A, ampere. Whereas in case of the charge, the symbol is Q for the charge and its unit is capital C, coulomb. Whereas in case of the potential and the unit, both of them have the same symbol, that is capital V. Now the same thing, from here you will get the potential difference. Only if you remove this from infinity, when you bring the charge, if you bring from one region or from one end to another end, suppose this point is at infinity in case of the potential. Okay, now this infinity is brought very close, you say, let us say from point A to point B, then in that case this potential will change into the potential difference. So let us do that also, the potential difference. So in the potential difference, what happens is, basically the potential difference is also same as the potential. Here also you have the same formula, the work done, but in case of the potential difference, the infinity, you don't bring charge from the infinity, you bring the charge from one point to, from the finite region, from one point to another point. So let us define the potential difference. Okay, now potential difference is defined as the work done per unit charge in moving a positive test charge from one end or from one point to the other. So that is the main point, main difference rather, between the potential and the potential difference. Suppose you take point A and you take point B, alright, and you are bringing the positive charge, okay, in a positive test charge from point A to point B. What you do? You do the work. So that work is what? It is the potential difference. But if you bring this charge from infinity, then it becomes the potential. That is all you need to understand. So the potential difference between A and B is given like this. It is work done by bringing the charge. So you are bringing, so we can also say that the potential, suppose this is the conductor and this is the point A and point B. So when you take the charge from this end to this another end, then also there you have a potential difference across the end of the conductor. Whereas in case of the potential, you bring the charge from infinity, alright? The unit will be same here. The SI unit will be also volt and the symbol will be also capital V. So this now potential difference is quite important from your numericals point of view, because we will be discussing only the point from one point to the other while solving the numericals. So now we come to the final term or final what do you call, physical quantity in terms of these charges, in terms of the current, in terms of the electrons moving around in a wire or in a conductor. So the last term that we discuss is resistance. if you look at the word resist, all of you know resist means to decline or to to kind of obstruct like that. So here what is being objected or what is being obstructed is the flow of the current in a wire. Suppose this is a this is a conductor, and you have the electrons inside this, and these electrons are moving here. All right, these electrons are being moved here. So what happens is, when there is some kind of obstructions, to the flow of the electrons, then that is defined as the resistance. So resistance is defined as the obstruction offered to the flow of the current in a conductor. So resistance, it is defined as the obstruction offered to the flow of current in a conductor. Alright? Now what happens is, in any metal or in any wire or in any conductor, it has the structure of these metals is such that there is a orbit, alright, or the layers. In that orbit you have the presence of electrons, and when you go to the nucleus, then there you will find the presence of protons and neutrons. This nucleus remains intact, but these electrons in the outermost orbit are free to move. So those electrons are called free electrons, and they move. So if I take one metal or anything, and in that metal, in the outermost orbit, it consists of some free electrons. Along with that, you have some equal number of the positive ions. For example, this dot gives you electrons, and this plus gives you the positive ions. In a conductor, there are infinite number of electrons. So I'll just tell you the few. I'll just show you the few. In fact, it has got equal number of electrons as well as the positive ions. They are balanced, in fact. So when this metal is in a free state, when it is not connected to any circuit or wire, then there is a random movement. These are moving randomly. It moves randomly in any direction. It does not follow any directions. The electrons, they move now continuously. They move, there is no particular direction. So what happens is, the end result is there will be no current produced. The current will not be produced. But when this same electrons, and the positive ions, so I am just showing you few here. If the two end is connected to a source of current, or let us say it is connected to a battery, let us say it is connected to a cell. Now what you observe here is, when it is connected to a cell, then automatically these electrons will align in one direction, that it will be always directed towards the positive terminal. See, this is the positive terminal, this is negative. So it will start flowing in one particular. So now what happens here is, there is a continuous flow of electrons. So when these electrons are moving now, its speed increases, it will gather the force, and when this speed increase, they will collide with these positive ions, and some of the energy is lost. Due to that lost energy, the wire gets heated. You must have observed that when a wire is there, and when the wire is connected to a circuit, to a cell, the source of current, the wire is quite hot. It is heated up. So it is because the energy is lost due to the collision. Now again, after some time, what happens is, this process will continue. As long as it is connected, the speed will decrease. Then again the speed increases, then again it will collide, then again the energy is lost, and again the wire get heated. So this process will continue. So when this process continue, okay, when this process is continuing, what is happening here is there is a continuous flow of current taking place. Whereas in the first case, there is no outcome. The current will not come out here because they are moving in random direction. Whereas here, it has got one direction of the electrons which are present inside. So it is moving along the positive terminal. So now here, what happens is the metal in the second case, since the metal gets heated, so that metal will offer some obstruction, resistance to the flow of the current or to the flow of the electrons. So that obstruction is known as the resistance of a wire. Now this resistance of a wire is given by capital R. In order to understand the resistance of a wire, we will come to another topic where there is a relation between the potential difference across the end of the metal. Now see, this is the potential difference created here and the current flowing. There is a relation obtained here between these two physical quantity, and from there we come to another important law that is called Ohm's law. This Ohm's law was actually it was observed, or it was discovered by one scientist, I think some French scientist. The name of the scientist is Simon Ohm. So that we are going to study in detail in the next class. Thank you very much. Keep studying, and you have to start doing the exercise from this chapter. I think exercise 8A. Thank you very much.